If you're confused by now about what the real story is about this whole El Nino business, then don't worry. It is actually quite confusing. So much is known, so many papers are written, and you can always ask some simple questions and there is no answer often. Okay, so evolution of ENSO conditions 2012 was interesting. Eventually it is seen as part of a double dip La Nina from 2010 to 2012, but 2012 saw a little evolution of a warm sea surface temperatures in the east, but model said maybe it will be a weak El Nino and actually didn't evolve into an El Nino. 2014 evolved into a much stronger looking El Nino like condition. Model said El Nino is coming, but it didn't qualify as an El Nino by some definitions. But now, if you go back and look at the Nino 3 time series, you see that 2014 was getting warm. We'll return to this a little bit later. And 2015 became a strong El Nino. So was that a double dip El Nino, or was it just something that was related to recharge discharge? So obviously you can look at September 2012 and then September minus August. You can see that actually September was colder than August. And if you look at 2014 October, it looked warm. But if you looked at October minus September 2014, then you can see that the structure is not so clear. So for the Bjerknes feedback and the coupled feedbacks between the SST anomaly, thermocline, winds, and SST gradient, pressure gradient, etc., you need a certain strength of the anomalies at the surface and below the surface. If they are not supporting each other, then obviously El Nino may disappear. So raises a question about whether recharge discharge are just sufficient conditions, or are they necessary conditions, or are they necessary and sufficient? It turns out that mostly they are necessary conditions. Maybe there are events that are not fully coupled, like Amy Clements' thermally coupled Walker mode, which we mentioned before. But if full coupling of some sort, weak or strong, has to happen, it looks like recharge discharge is a part of it, and different flavors of El Nino may have a slightly different pathways of the recharge and discharge. Keeping all that in mind, then you still don't know exactly whether El Nino is a stable oscillator or not, but still it comes to a question of explaining the different, number of years between two El Ninos. It's not always very regular. So the idea is that there are uh, events in the system. Maybe they are weather events. They act like triggers. And that trigger may be acting on the discharge that is already there. So discharge is a necessary condition, but it's not sufficient. And then you have these things called westerly wind bursts. And this is again a figure from NOAA, which is going from July 2025, summer of 2025, into June 2026. I'm recording this just a couple of days after the figure was produced. I'm stealing it. And this is the equatorial upper ocean heat content. So you integrate it down to about a couple of 100 meters to see how not just the surface temperature but heat content is varying. And you see these wave-like features that are going from west to east. Time is going down. So starting earlier here, reaching later here. So these are cold temperature or heat anomalies, which means they are upwelling Kelvin waves. They require the eastward wind anomalies or easterly anomalies. We don't say so much easterly wind bursts, but we talk a lot about westerly wind bursts, especially in the West Pacific, and you can see that it started to be warmer than normal here about fall of 2025. Then you started to have these repeated westerly wind bursts, which are, they have a wind speed associated with them of order, let's say, 10 meters per second, and they have to last for about 7 days. So they're still very much weather events, the definitions are not very strict, and we don't always know the origin of these westerly wind bursts. Some people say they are extratropical surges into the tropics. Some people say it's part of the Mad-Julian oscillation that's going from the Indian Ocean into the West Pacific Ocean, but they mostly occur in the West Pacific Ocean in the far west. Let's say like it's starting here around 30, 40 degrees to the east, to the west of the dateline, and you see some form of a weak Kelvin wave, a downwelling Kelvin wave, which is convergent and is pushing the thermocline down, which means by the time you reach the end, you end up converging and deepening the thermocline and creating a warm pool of water. Clearer here, much clearer here. So if you have repeatedly these things happening, then you get these downwelling Kelvin waves and deepening of the thermocline and warming below the surface, which typically means warming at the surface because you have mixed layer processes that are entraining these waters through upwelling. Upwelling doesn't completely disappear, as we said, gets weaker, but it's entraining warmer water, so you get warmer temperatures, and then you can have Bieknes feedback. So this is for 2026. You can see that December 2025, we are in a kind of maybe a mild La Nina like state, but again warmer on this side and some upwelling Kelvin wave here into the spring of 2026, and then these are winds, so you have to be careful. 850 hectopascal wind anomalies, zonal wind anomalies averaged over 5 north, 5 south. So you can see that there have been wind bursts. Sometimes wind bursts move eastward. What happens is there is that front we talked about between the warm pool and the cold tongue. Westerly wind burst is typically starting on the western side of the front, and it has the ability to generate waves but also push the front eastward, and as the warm pool expands, the wind anomaly can get larger in its fetch and maybe strength. So the noise that it is when it starts becomes what is called multiplicative noise, which means it begins to sustain itself as it pushes the warm pool eastward and expands the warm pool and finds the energy to continue to fire up. Okay, so this looks like one of those multiplicative noises because now you are not just a weather noise, you are part of the coupled system. Okay, so this kind of a study was extended. There are several such studies. This used a simple model to look at the El Niños from 1982 through to about the 2015 one, and argued that these are again wind anomalies. And you can see that the wind anomalies always exist with the El Niños. These are La Niñas, El Niño, La Nina here by July 97. And cold periods. Basically, the idea in this paper, even 2014 had westerly wind anomalies which didn't go past the dateline, but in 2015 they got strong and went past the dateline. So you can assume that when they go past the dateline, like here in 82, 83, 97, 98, and 2014-15, this fired up a little bit of a warm anomaly on this side in SST that we are looking at winds, so be careful. But when they go past the dateline, they have become a big part of the coupled system and multiplicative noise, so they can kick up an El Nino with the coupled feedback. Okay, so you can look at this in a bit more detail here. And so onset affected by the duration, intensity, and frequency of the westerly wind bursts. So this is another paper, not the same one. This one was by Dak Chen, and I was involved in this. This is a newer paper that looked at how you can classify El Niños into early onset. So the onset seems to happen early on in the spring months, like the 2026 one, and you can see that the westerly wind bursts get stronger and come far east of the dateline, and then you produce a strong El Niño. But if the onset is late in the later months of the summer, then the westerly wind bursts do not get as strong or as large in their fetch in time and space, and you get a weaker El Nino. Maybe the warming is not so close to the coast here, more to the central Pacific. So it just says that maybe this whole central Pacific, eastern Pacific El Ninos are just a diversity that is based on how these synoptic winds are creating coupled multiplicative noises that can grow the El Nino into one flavor or the other. The question is not completely answered yet, of course, but they look at the ocean heat content as well for early onset El Ninos and late onset El Ninos, but also the preconditions. So 2026 looked pretty much like this. It is an early onset El Nino with preconditioned discharge that was already by in the eastern Pacific by the time spring arrived, and in June it's full blown here with warming near the surface and so on. With the late onset, then the discharge is still going on in the summer, and you still have cold pool of water here, which means upwelling is going to bring colder waters, and then you may end up with a different flavor of El Nino. Does this really explain everything? Well, again, remember that we are mostly doing diagnosis of past events. They are not necessarily prognostic in the sense that in a model, these have to be internally generated. Models have to generate easterly wind burst internally. Will they be as realistic as the real world? Not always, but there are many issues associated with how models do it and whether models do the El Nino structures well and so on and so forth. We'll come back and look at one very interesting decay case of an El Nino. 1997-98 provided a very dramatic decay of the El Nino. It flipped suddenly from strong 97-98 El Nino into very strong La Nina by the summer of 1998, and this was recorded in the biological signature seen as chlorophyll in a new satellite that had just been launched called CWIFS. So I'll come back and look at that, provide some interesting insights into how the termination of an El Nino happens. Okay,